Hi there. We'll go ahead and get started. My name is Dan Kohn, and I'm the Executive Director of the Cloud Native Computing Foundation. This is definitely not, well, I guess we officially pitched it as the intro deep dive of Conformance, but I think we're going to focus this pretty intensively on a deep dive. I did want to just give the context that we started this program 2 years ago. Arguably, of everything that CNCF has done, including KubeCon, this has been the single program that's had the biggest impact. So we took the conformance test suite that had already been built into Kubernetes and then created a program around it to allow organizations to self-certify. When we launched 2 years ago, I think it was with 22 or 24 vendors, which we were utterly thrilled with. We're at 102 now, though, which is really spectacular. And given the large number of acquisitions going on in the space, this number probably will go down a little bit, but then there's also a bunch of new folks coming in that may make it stay the same or go up. So I think we're very much at the phase of a conformance program where we are at the end of the beginning, and there's the program itself in terms of organizations getting involved and signing the paperwork around it and then having a way of submitting their tests and such is all working, and the program was designed in a very explicit fashion to require people to stay on the release train. So the conformance is only good for a year unless you certify a newer version, in which case your older ones can stay conformant. And so now I think we're in the sort of grittier middle of the section, which is about trying to make the conformance mean more and do more, and that is really about measuring what our tests are covering now and then writing the additional tests to cover more. And it turns out that this is just a challenge that has been, I think, deeper and had more complexity to it than certainly I would have expected, but I think for most of us. So with that, I'm going to hand it off to Hippie first, I think, and I'll just be watching. So thanks.
Actually, we'll start with me. I'm John Belamaric from Google, and I'll talk a little bit just kind of about the introductory material. I'm just going to stay down here. This is a really small group, which, by the way, you can come closer. You don't have to be so far away, rather than standing up there where I can't see the slides. So just as a sort of introduction, as Dan was saying, this program is intended to ensure that we protect the brand of Kubernetes. So any vendor that is claiming to be Kubernetes needs to meet a certain level of certification, and we want to make sure it's so important for the confidence and trust of our users that Kubernetes running, from Google and from Amazon and in your VMware machines all work the same way, essentially, right? That we can move workloads portably across things. That's part of the promise, is the idea of workload portability. And sorry,
it's loading really slow.
Oh, okay. So there's two parts of this program, and I don't know where the slides start, so maybe, okay, looks like we're coming up. Yeah, just the next slide. So what is certified Kubernetes? Like Dan was saying, it's this software program. It's vendors take a cluster created by their Kubernetes platform or their Kubernetes distribution, and they run a suite of tests as a subset of the Kubernetes end-to-end tests, and then they provide the output of that back to the CNCF, who validates that that all of the things that we consider mandatory part of Kubernetes actually meet those requirements. And if they do that, they can get this beautiful little badge that they can include in their product. They also can use the word Kubernetes in their product name, which they wouldn't be able to do otherwise. Again, we want the portability, we want the interoperability. We want to make sure that we don't fragment the Kubernetes, the whole Kubernetes platform. Either fragment it in terms of version fragmentation, so we want to make sure that people are upgrading and maintaining newer versions, or in terms of vendors. Again, I think I've already sort of said this, but for end users, it means that they can have a lot more confidence that any workload they're running in any particular environment can be made to work in another environment. Now, every vendor, of course, wants to differentiate, and so we try to leave enough room that functionally things work, but of course, one vendor may have better networking or something than others. There are pluggable interfaces to Kubernetes, and we need, from a conformance point of view, we need for the distributions and those pluggable interfaces to work in the same manner and functionally the same way, but there can be some differences between them for differentiation. If you are a distributor or a vendor, you definitely want to certify, you want to get this little badge, and you probably want to use Kubernetes in the name of your product, which you can't do otherwise. We split the conformance program into two aspects, and Dan alluded to this a little bit, but the CNCF actually runs the program of certification. So the CNCF is what you submit your results to, and they have the authority to grant you that badge. What we do have, though, is in the open source community in SIG architecture, there's a conformance subproject. That conformance subproject does two things. One, defines the actual behaviors or tests or functionality that is considered required for conformance. So actually defines what Kubernetes is, and also implements an open source set of tests to, or coordinates it really. Other SIGs typically implement the test, but coordinates that platform to actually do the evaluation. So the mechanics of what the tests are, what the behaviors are, is determined by SIG architecture. The actual execution of those tests and evaluation of the results for a given vendor is done by CNCF. So that's all on the sort of intro level, very high level. I'm happy to, maybe what we should do is have Hippie go through some more information on a sort of deep dive level of what the current state is as far as coverage and things like that. A lot of the effort right now in the conformance program, as Dan alluded to, is increasing the coverage. We have a limited amount of coverage. We probably need tenfold the coverage that we have in order to really make it a strong program. So, but Hippie can step in and talk a little bit more about that.
Thank you, John. I appreciate your introduction, and thank you, Dan, for setting up the program for us all. I know that it's critically important for me and my country that the software that we create together runs everywhere on the planet. Without that assurance, I don't have time for this. We have to go do something else. But I think this is one of the platform that we can standardize on and ensure that our workloads can run globally. I'm going to do this a little bit differently and split it into a couple of parts. I invite you to take out your laptops, if you have them with you, for a little bit later. I'm going to invite you to come and do this presentation with me, because we're going to try to actually help define the surface area of both the planet and Kubernetes. Because if we know what that surface area is, we know what we can build upon, and we know what is safe for all of us to have a shared agreement. And that is evolving. So having your input with me today would be delightful. Get my easel and paintbrush out and see if I can take you on a little journey. I'm going to close these slides, and I'm going to close this slide, and there's all of our certified Kubernetes vendors. I'm going to close that slide, and this slide, and this slide. And we're going to talk about clouds. And the resolution at which we've been able to see the clouds. Is that F11, that screenshot? There we go. This is a screen, a TV broadcast of our Earth and the coverage of the clouds back in 1960. We had very limited resolution at the time, and it was one of the first broadcasts from the Tyros-1 satellite. Find the right keys to hit. And in 1990, we made one of the most famous selfies. It's called Small Blue Dot. It was taken from Voyager. You can't see it, but in this little red band, there is 1/4 of a pixel resolution of what it looks like from 30 degrees above the ecliptic to see the whole Earth. That was from Voyager 1. This is probably the most famous selfie in the world. This is called Blue Marble, and it was taken from the crew of Apollo 17. The resolution is much higher. We can see some land masses and the color of the ocean. Go forward to 2001. Now we've got lots of sensors and metrics coming in from all the satellites everywhere. And so we actually have our full view of Blue Marble 2 from NASA. And they combined all those images. This is a problem in a lot of presentations around the world, is they forget to include this small country down at the bottom, New Zealand, because of the aspect ratio of the way that we focus everything. I did my best to include New Zealand in this one. This is a little bit later in 2002, where we started to have enough data and also being able to see the whole Earth without clouds. This was a single pass over in a day, one of the first times we were able to accomplish that, at least that we're aware of. Remove the clouds, and you can still see all of the frozen water and the liquid water and our land. Remove that back to the land, minus the ice, and you can see just where things could be productive. And if we focus a bit further at night and turn off the lights, we can see where the people are. And this is what's important to me, is to find out if we're going to deploy this stuff, let's make sure it's for all of the little lights you see up here, not for some of them congregated in one area. The reason I'm working with the CNCF and enjoy their vision is they are about building sustainable ecosystems. And these ecosystems need to be able to encourage all people to participate and to be able to benefit from this collaboration, this global collaboration that we're doing. The CNCF also fosters communities like the Kubernetes community. I think we're doing some things for the first time in humanity where we're able to coordinate and do things in an open governance way that is global. It's, to me, feels we can progress the things we're learning here into more organizations to how we do open governance and how we attempt to coordinate our efforts. For this program, this is going to ensure that we actually can take the benefit. Everybody gets the benefit because we'll be able to take all of our workloads and run them anywhere in the world. And we'll know for sure if we have the certified logo on that implementation or that vendor. So I'm going to go back for a minute to a parallel of all of those imagery, back to our journey with Kubernetes. Our first faint images of visibility were back in 1.10, where we were parsing EDE log files thanks to Ken Omichi. And then in 1.11, we started looking into the audit logs that were available when you configured them. And that gave us a static website with a little bit of coverage information. The real view came in when we started getting actual test coverage, where we had user agent support added. And at this point was the first time we got to see what the coverage was. I think in 1.10 it was somewhere around 11% when we had our first meeting that said, whoa, this is probably good that we know we have full coverage, and it's at about 10 or 11. When we added user agent support both to the API server and to our testing framework, we were able to tell when a test was hitting Kubernetes. Progressing to 1.13, we're starting to get a lot of satellites, or in this case, using test grid and all of the CI automation to look at lots of audit logs, We set up some API snoop.cncf.ci to start processing those audit logs and give us a view across time. 1.14, we were able to have dynamic queries via having a database where we could query the Kubernetes API surface area to actually understand what it was comprised of. We were also able to turn all of those, take that JSON and put it into SQL so we could query it and look at our audit logs to compare that coverage in a way that was done via programming before. So we could ask new questions. 1.15 was a really cool release in that we started gating what was added to Kubernetes to ensure that we didn't add anything new or create more surface area, create more land that people couldn't safely build infrastructure or be productive on in the cloud. There was actually posting of API links to API Snoop in issues and tickets saying, you've got 3 more to go, you're almost there. These are the exact 3 surface area endpoints that we need test coverage for. And I'm happy to say we've got 3 groupings that are fully 100% coverage now. And I've had conversations with many of the SIGs this week so that we can get it over the line and get the 100% in as many areas as we can. 1.16, we're still trying to define what surface area means. We came up with this idea that when you query the Kubernetes, it'll tell you, here are all the operations you can do, and here are all the kinds of things that you can do, the objects you can do operations on. And it gives us almost a thermometer type check, but we don't know the full health or behavior yet. And John's got some interesting things that he's been working on with his team, and combining together with the database and queries, we're going to actually go through and talk about that. And I'd love to get your input on precisely defining what it means to measure the surface area of the Kubernetes itself. And I think that's pretty much for the fancy slidey things. These are the links for K8s Conformance and API Snoop. The first one is the CNCF repo where everyone who wants to become certified can submit their test results. There are 2 things you need. You need to submit your test results for the version of Kubernetes you want to be certified for, and you need to be a CNCF member. If you want to understand what's the current area is, and we'll go to that link in a moment, is apisnoop.cncf.io. It helps us understand the surface area, what's covered, and what can come next. And we also have a repo that accompanies that. Just a quick look at API Snoop itself. Oops, I hit full screen or something. So this is the web interface that we've been using to link to up till now. And it may take a minute to load, so we'll come back to it. No, not too bad. The surface areas you see in this picture here, the red things are lava. It's where new things are being formed, new land is coming together. And blue is beta. It's where it's starting to cool down, hasn't solidified yet, but it's on by default in your cluster. So you can give it a try, but don't depend on it yet. It might change slightly. The green area is where it's super safe and generally available for everybody to build their everything. But we have to agree on what that is and make sure that it's a really solid foundation for us all. If I zoom into what could possibly be the stable foundation for us all there, we'll notice there's actually a very specific number of endpoints or operations. And we can tell how many are hit by test in general and what percent is hit by conformance test. It's useful. We can see the groups. Here's one of our groups that's completely covered under admission registration. If I click on that, you'll see that all of the little outer wheel is filled in. If we go back to the green and choose one that's not yet, let's choose storage. We'll choose auto-scaling. Auto-scaling has got 3 endpoints, but there's still 10 endpoints that need to be covered. Oftentimes, I'll help a SIG or an organization identify when they're trying to promote what's lacking, and if they try to add new endpoints, helping them to ensure those are covered. Can I get a time check? How much time we have left? Okay, plenty of time? Plenty of time, okay. I'm going to go into another area, and I'm going to close these things. And let's Go here, here. We might find a color. I'm gonna go through a few colors till I find something that everybody can read together. Space. Would you prefer a bright color or a dark color? Bright's good. We can see. Okay. So I went ahead. We have a template that we go through with our team to help identify what it is that we're going to focus on helping the community next as far as writing tests. This template we go through and helps us to ensure that we're all doing it the same way. And I'm going to encourage you to join me in going through this. We can actually share these terminals with each other. We call it pairing, so that we can transfer knowledge from people in one SIG or within our own team to get all on the same page. I have another window here on the right, and I will, as we're going through this, it should write things over there. We go through and give this checklist, but I've already done 90% of it for you to go through and set up our cluster and create a Kubernetes cluster using Kind. One of the things that we've found that helps us is the audit logs, and you can actually ask your API server. It's still alpha. I'm looking forward to when it's beta, so it's available to everybody. So we ask our cluster to please send your logs to a specific service, and we bring up this database of API Snoop inside the cluster. So this process that we go through helps us look at the existing surface area, and I'll show you how we define that. And then you can run your applications that are important to you and see the areas that they hit that are not yet conformant, so you can advocate that they get test written, either by spending your team's organizational time to write those tests, or let us know that they're important to you so we can prioritize them. Our team uses it to identify the test that's next inside of a ticket, and then go through and find the documentation, and then find the expert in that field. You may not be an expert in it, but you use it, so let's find the right people in the SIG that own that API. We have a walkthrough that this basically goes through and does a kubectl apply of API Snoop. So that's how simple it is to get API Snoop installed. Make sure that you have audit logging enabled on your cluster, and then you kubectl apply. Then it allows you to have the ability to query. We're going to go through and do those queries here in a minute so you can see the definition. Let's make this super simple. API Snoop's been applied. We've verified that all of our pods are running. And we have port forwarded things so that we can get access to there's a PostgreSQL instance, so that the simplest way to help define coverage is just to query the API itself on what you're interested in covering and looking at all of the APIs that have hit it so far. And we connect this file that we work on to the DB. So this, let me get rid of here so we can focus all in one place. Can't see the mouse. There we go. So this query right here, we have a table for stable endpoint stats where it's not the live data from your cluster. This is the latest CI build from, it used to be merge blocking for master, but I think it's merge informing now. What's one decision we need to find out? What is the best source material for comparing the baseline? The reason we need a baseline is we need to make sure that baseline never goes down, but we're always increasing the percentage of surface area. So if we add more surface area, it must include tests. Otherwise, what's happened a few times, we'll have new APIs added, and we'll note there's not tests, and the numbers for getting us there go down. And we're in the process of creating a PR that's going to make comments at first, but a PR blocking job that won't allow new APIs for all of us to build upon into the release unless they have tests as well. This is really important. If we go through a bit further, at this point we usually let the DB sit for a bit. This is where we go through and identify a particular feature we want to focus on. This is just a SQL statement that says, go find the stable things in core that have no test at all. And don't look at the live feed just yet. We want to look at the stuff that came from this baseline. And let's order it by how many times it was hit by things other than EDE. And so this is a sorted list of the times that these were hit. And there was a suggestion at one point that we find stuff that's not hit very often just by a few tests, so that we know that they're not accidents. They're actually intentionally hitting those endpoints. So that might allow us to focus. But I'm open to other queries, but I'd love to pair with folks. We can just change anything in this text and run the query again. Or I'd love to pair with you another time when we can both dig into your area of expertise or your SIG and focus on finding exactly where you can help increase our conformance coverage. I'll go ahead and close this area out. That's identifying the feature. Then normally we have another section that is, for our template, very light, because once you've identified the endpoint to focus on, we want to go find all the documentation, become versed in the vocabulary so we can identify the right people to talk to, the experts, and create an issue that invites them to look at the code that we will write shortly. And that's what I'll do in our next little snippet here, is write your test. This is where you don't have to learn how to write everything in the EDE framework yet. You don't know how to even write full-on Go. If you'll put some example code inside this block and execute it, it will run against your cluster and will allow us to, without needing to be experts, at least ask really intelligent, pointed questions with examples and output and the endpoints that it hits so that we can onboard more people to getting us. We have 10x to go. Let's get there as quickly as we can with as many people as we can. So I'll go down here. I think this is a pretty cool thing. I haven't seen this in any other type of way of coding, but we have these things that we do with code blocks. And inside the code block, it's just a really simple snippet of code. It's only, what is that, not even 15, 20 lines long? And it's not all of the Go stuff. It's just, let's go get a kube config and get a client set and run one thing on 278. Let's list some pods. What do you think is going to happen when we run this? In this environment, whenever we actually run it, it's executing right now, and we'll update. Yay, at the bottom, there are 11 pods in this cluster. If I were to go through and delete the results here and run this code again, we could see that it's actually compiling that into Go and executing it. And what's useful here is we can now go and verify that that was hit to say, what did this example hit? First is our, we load this, oops, sorry. Here's our current conformance, so we have something to compare against. Takes a little bit of time to do the query, but not too bad. So this is our, the upstream job and the date that job was run on. It's a little bit behind because of KubeCon prep. The number of endpoints at that time, we're talking stable operations, how many times it was hit by test and how many times it was hit by conformance test. So we have the number of endpoints hit, so we have this percentage, percent tested or conformance tested. I can go through these queries with you at another time if we wanted to dig into it. The next thing is to see what, in this question, we're asking what was hit by the new code snippet that we wrote. So you don't have to be experts in it, but we can understand that hit by new test, list core v1 pod for all namespaces was actually hit 3 times, because I've run this 3 times now. But if you were to actually, you could actually see exactly how many times you could reset it and experiment with how do we increase coverage in a way that the experts agree on, that we are very precise in our description before we go write any tests. We've been working hard with the community to try to write meaningful tests, and I think we've discovered that we need to wait to write any test until there's some type of lazy consensus on the right idea before we spend that time. And I think this will help us get there. The last area, as far as our workflow, is actually to say how much will this particular issue, if we were to create a test from it, how much would it increase our coverage by? This is the core of not only how important is this test to be written, it is also the core of the bot that says, you shall not pass unless you make sure that our conformance and coverage for the basis of how all of us deploy our workloads worldwide is safer than it was before you came. This particular test did not increase because we hit an endpoint that's already tested. But I look forward to working with each of you and your SIGs and within your companies who have important applications that need to run everywhere to increase our coverage in a meaningful, precise, and explicit way.
One thing I'd like to mention, I think that's useful also because we want to avoid tests that are sort of accidentally hitting endpoints in a Rube Goldberg-y kind of way. So if you look at your list of things that are hit by the new test, you could, if that list is really long, you're not necessarily going to count all of those, right? So I mean, it helps you keep a lot of clarity around making the test precise.
One of the things, if there's any questions, but one of the things we like about our workflow here is that I can actually, at this point, take this entire document, including the code snippets and the standard out and the queries and the results, and hit some keys and post it into an issue without having to format a document or go through a lot of process. So we're hoping that the more people that learn to pair and cross-SIG, cross-pollinate, if we pair together in this way and can create enough tickets momentum, we'll actually be able to do this insurmountable workload in a much more reasonable amount of time than it would take if we were just to use, Any questions? Okay, well, I will. Go for it. Can we do this real quick? Is it on? On. There you go.
My understanding is that conformance testing endeavors to make sure that particular parts of Kubernetes work on any platform or any architecture or any environment. Has there been thought to upgrade, downgrade testing, making sure that the versions of Kubernetes and their components work in relation to each other? Is that not the conformance working group's concern? Is that, should that be someone else? Where is that?
It's absolutely important. It is not part of the conformance working group's role.
Okay.
But there are, and I can show you exactly where the tests are in test grid, where we do upgrade tests across the last 3 to 4 releases all the way up. It's not a per vendor thing, so it's not a way that's kind of up to the vendor to ensure they upgrade well. But as far as ensuring that the base components of Kubernetes can withstand and survive the upgrades, there's a whole other area of testing. But no, it's not part of conformance.
Do you know what working group or SIG that does deal with that?
Off the top of my head, I'd say SIG cluster lifecycle.
Cluster lifecycle? Okay. Thank you.
You're welcome. Okay, well, I'll let you all go home early, and thank you so much for your time. I look forward to pairing with you in the coming months.